Let's take another design problem. Here you are asked to program an 8 to 1 MUX to realize the following equation, which is this one. You cannot use any additional gates and your inputs are restricted to A prime, A, B prime, B, C prime, C, D prime, D, logic 0 and logic 1. So given this particular problem, I'm going to show you a technique in which you can program the MUX. So remember, your MUX or your 8 to 1 MUX is going to look something like this. Since it's an 8 to 1 MUX, it's nothing but 2 raised to 3 to 1 MUX. So you have 3 select lines. So select line 1, select line 2, select line 3. And you're going to have 8 inputs. So these are 8 inputs. And this is 1 output. So the output is G. And your inputs are 8 in number. So 1, 2, 3, 4, 5, 6, 7, 8. So this is port 000, 001, 010, 011, 100, 101, 110, and 111. So the ports are described by your select lines. So if your select lines are 001, then you select this guy here. So I'm going to show you a technique now. The first step is draw the truth table. Once you have all the combinations, find out the output G. So your G is going to be 0, 0, 0, 1, 1, 0, 0, 1, 0, 1, 0, 1, 1, 0, and 1, 1. So using this equation here, given here, you can find out the output expression or the output G. Now to start programming the MUX, the first step that I'm going to do is I'm going to use A, B, and C as my select lines. Okay. Now I need to find out what these items are over here. So what should be the input for port 0, 0, 0? What should be the input for port 0, 0, 1? What should be the input for port 0, 1, 0? All the way up to what should be the input for port 1, 1, 1. And the way you try to do that is, now let's go for port 0, 0, 0, which means A, B, C are 0, 0, 0. Therefore, you have to check these two combinations. Okay, when A, B, C are 0, 0, 0, your output is a 0. Your output is not dependent on input D. Therefore, we are going to program it with logic 0. So this input will be logic 0. Next, go for 0, 0, 1. That is this combination. When A, B, and C are 0, 0, 1, your output G follows D. So when D is 0, your output G is 0. When D is 1, output G is 1. Therefore, it's D. And we write D. Let's go for port 0, 1, 0. That is when A, B, C are 0, 1, and 0. Your output G is the inverse of D. So we are going to write D prime. And we write D prime. Let's go for 0, 1, 1. So that's this case here. In this case, output G follows D. Therefore, your input should be a D. Let's go for 1, 0, 0. For 1, 0, 0, Your output G follows D, therefore your input should be another D. Let's keep going. For 101, your output G follows D, therefore your input is a D. Let's see for 110. For 110, which is this combination, your output G is the inverse of D, therefore we write D prime. And finally, for 111, which is this combination here, your output G is 1. It's no longer dependent on D. Therefore, we are just going to write logic 1. So this one would be logic 1. And that is how you program the 8 to 1 MUX.